Look at the question. Given a 7-element array with distinct elements, what is the minimum number of comparisons you need to find one element that is neither the maximum nor minimum? Yeah. So that's the condition. Yeah. We only need to find one such element. Yeah. Okay, satisfy this condition. Okay, all right. And we want to use minimum number of comparisons. Yeah. All right, to answer this question, yeah, try to avoid using too many comparisons. Okay, yeah. Because if there is some way many students may, tend to apply in this way, like, because neither maximum nor minimum, all right? Yeah, not different from maximum and the minimum. Yeah. Then some students may take it this way. Yeah. Find max and min first. Okay? Yeah. So here, one way. Yeah. So here I said one way to do it. All right. Find max and min first. Remember, we have algorithm, right? In module 1. At the end of module 1, we have one such algorithm that can do that. Yeah. Remember, with formula, yeah, can do that. After you find the maximum minimum there, you just pick any element other than maximum minimum, right? Yeah. So pick any one other than max and min. All right. So this is an obvious way. I want to say this is some way many people tend to use at the beginning. Yeah. But this way, you won't get a good solution. So yeah, let me say, if you do this way, it's not a good solution. Yeah. The reason why you do not get a good solution, the reason is because you do not get the insight. Yeah. Yeah. In this way, you didn't use the insight. You didn't get the insight of this question. What is the insight here? Yeah, the reason is you didn't catch the insight of the question here. All right. Yeah. So here, regarding the insight, we need to find the most important property of the question. Okay? Yeah. So here, we need some element. We need to describe element X in the given set such that X is not equal to max and X not equal to minimum. Okay? So here, this condition, this is the key condition. Yeah. We need to find some simple way to represent this condition. Yeah. Not a max, not a minimum. Okay? Yeah. All right, so here. The first method, the reason the first way did it poorly, yeah, because it calculate max and min directly, then eliminate max and min, then select anyone in the remaining element. But when you calculate max and min directly, you do too much work. Yeah, so here, because you calculate both max and min, you do this many comparison, you do too much work. You do not need to do this much work. You overdo it. Yeah. You overdo it. Okay? Yeah. Because our goal, this is our goal. Our goal, not a maximum, not a minimum. Yeah. So we need to find easier, faster way to tell us some element is not a maximum, some element is not minimum. And it's not necessary to find maximum and minimum. It's here. You need to, so in your mind, you need to understand, you need to get to this point. So what is the point? Yeah. Get to this point. Yeah. No need to find max and min in order to know some element is not a maximum, not a minimum. In order to know that, no need to find. Yeah. Okay. Yeah. Can you see this point? How can we not finding maximum, not finding minimum? We can say some element is not maximum and not minimum. Can you get to this point? This is the key point. Okay? The key point. Yeah. Related to the inside. Okay? Yeah. Here, let me point a critical property here. Okay? Yeah. All right. Yeah. Let's look at one special case. If x1 less than x2, then x1 is not max, right? See this property. Yeah. And we don't need to touch the maximum. We don't need to know which one is the maximum. You just do one comparison. The smaller one cannot be the maximum. Yeah. The smaller one has no chance to be the maximum, right? Yeah. All right. Yeah. Similarly, The larger one, x2 is larger. The larger one cannot be minimum. Right? See? So one comparison, you can get this much information. X1 is not maximum. X2 is not a minimum. How about that? Okay? How about that? Right? Yeah. Yeah. Think about that. Yeah. Then, can you find a way along this direction to answer this question? Okay? All right. All right. Then, so here I already give you a lot of information, a lot of useful information. Yeah. In order to help you a little more, yeah, let me give you another piece of important information. Okay? All right. Let's look at the number of elements here, 7. Yeah. Here the question. The question. Why 7 here is important? Why this number 7 is important? Yeah. Okay? Think about this question. Is the number 7 here very important? Right? Yeah. Yeah. If I change from 7 to 6, is it a similar question? Yeah. Given a 6-element array, yeah, with distinct elements, I just cross out the last element, x7. You work on 6 element. Can you find solution? All right? Yeah? So here I want to say the number 7 is not that important. Yeah. Then I change to 6. Can I cross out another element? Oh, sorry. So we consider 5 element. How about that? Cross out another element. We answer the same question with 1 fewer element. Can we find a solution there? Right? Yeah. Then another step. Can we reduce the problem size to 4? 4 element. We take 4 elements from the given array, and we try to find 1 element, not the maximum, not the minimum. Is it? So let's cross out another element. Because here, the idea is, if when we reduce the problem size, we can get a valid solution of the original problem, right? We can still get a valid solution of the original problem. Yeah? And we also know the smaller the problem size, the easier to find a solution, right? The smaller the problem size, the easier to find a solution. Okay? So for that consideration, we keep reducing. So we cross out another element. Can we consider, because we try to reduce the problem size as much as we can. Okay? As much as we can. Right? Yeah? Yeah. And yeah, so when we reduce to the size 3, yeah, we have to stop. Yeah. Yeah. That's the, smallest problem size we can consider. We can work on this problem. Otherwise, the problem does not make sense, right? Yeah. 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 So think about, based on the information given here, definitely you need to do some analysis work. Yeah. You need to have good understanding. Yeah. With the given information, you need to, connect the dots. You need to connect the dots. Okay? Make the complete story. Yeah. So here, I cannot give you the whole story. Okay? I just give you several important pieces of information, but you need to connect all the useful dots to make the whole story to solve this problem. Number 17. Yeah. Given 15 elements, it is known that X8 is not in place. Yeah. So you know the meaning, right? So if we sort this array, then X8 cannot be in its right place. Yeah. You know, the right place when the array is sorted, so we treat those positions are the right locations. Yeah. So X8 not in place. So X8 is not in its destination location. Yeah. What is the maximum number of inversions in this array? Yeah. All right. To answer this question, we use some commonly used the problem-solving strategy. Yeah. So here, let's start with the problem-solving strategy. Yeah. So what strategy? Yeah. If a problem is relatively hard, then we can work on a simplified or easier version. Yeah. So we can modify the problem. We can modify the problem, make it easier. So the strategy is work on a simpler version of the problem. Okay? Yeah. All right. After that, then, because you have some intermediate result, then you apply the intermediate result to, you go back to the original problem because you have something, right? Yeah, some partial result. Yeah. Then you get the final result. Yeah. All right. So that idea, simpler version. Yeah. To get a partial result. Then go back to the original version. Remember, because the simpler version, if you compare with the original version, there is a gap, right? There is a gap. So you work on the difference part. Yeah. So to bridge the gap. Then you bridge the gap to get a final result. So that's the strategy we want to use on this question. Okay? Yeah. All right. What's the simplified version? Yeah. Remove this condition. X8 is not in place. This is a condition, right? Yeah. Think about, without this condition, can you solve this problem? Without this condition, given 15 elements, how to find the maximum number of inversions? Here, I hope you know the meaning of inversions, right? The definition, inversion. Okay? Yeah. So the direction of the subscripts is opposite of the direction of the, the values. Yeah. For example, So here, let's look at the xi and xj. Subscript I and j value xi value, xj value. Okay, so the inversion means I less than j. Yeah, so that's the direction of the inequality, but the value xi greater than xj. Yeah, so that's one inversion. Okay? So that means, this means xi, xj as a pair is an inversion. Okay, all right. Now you need to count under what special situation you get a maximum number of, or under what input. Yeah, because your array, the values, the specific values for your array, that's the input. For what special input you get a maximum number of inversions. Okay? Yeah. If you still feel you couldn't get it, then I teach you another way to get it. Here, this 15 number, relatively large. Can you change that number, change to a smaller number? Okay, all right, yeah. For example, try 4, okay? Change 15 to 4 elements. Yeah. So if you only have 4 elements, can you find the maximum number of inversions? Right? Maximum number of inversions. Yeah, you know. Yeah. If you can find correct answer, then you change this 4 back to 15. You can easily generalize your result to the destination case. Okay, all right? Yeah. So that's the second step. Then, after that, then now you add the condition back. Yeah. Add that condition back. But when you add a condition back, okay, yeah, focus on the difference part. Focus on the difference part. Yeah. The difference part, x8, is not in place. Not in place, difference part. Okay? All right. So then, if you do not, so look at, so you need to know for what input of the 15 element array you have the maximum number of inversions. Okay? You need to know that input, okay? Specific input. Then, look at that. Is X8 in place in that input? Yeah. Yeah. Think about that. If X8 is not in place, yeah, it's possible. If X8 is not in place, then your result, your current result already satisfy the given condition. Then that's your answer. But another case you need to consider. X8 is not if X is what did I say? Yeah, there are two cases, right? In place case and not in place case. Yeah. If X8 is not in place, that case, the given condition is already satisfied. So you don't need to change your answer. You just use your current answer. Yeah. But there is a possibility X8 is in place. There is a case. Yes, it is in place. If it is in place, then you need to move it out of the place. You need to change the location of X8. Move it out of the place. But when you make the change, make the move, make sure you reduce the minimum number of inversions. Yeah, because when you make the change, you will reduce the number of inversions. Yeah. Because our goal, we want to get a maximum number of inversions. So your inversion reduction must be the minimum when you make the move, when you move X8. Yeah, because your X8 has to be not in its destination location based on the given condition. Okay? Yeah. So try to, understand, all these important pieces. Yeah. All right? Okay, so we complete the hint of this question. Yeah. Question number 18. Yeah. In this question, I think most of you know what main method to use. Yeah. So that is because here it's a monomial, right? Yeah. We learned a special method called repeated squaring. Repeated. Oh. Yeah. Squaring. All right. Yeah. But in class, I have one topic I didn't cover. Similar technique called repeated cubing. Cubing. Yeah. All right. Yeah. Here we may need to use this. Sometimes repeated cubing is useful. Yeah. So that means when you need to calculate x cubed, you do two multiplications. If x to the 9th you do the cube way. Yeah. So here, two multiplication. Yeah. And sometimes you may need to try this way. You can do slightly better. Yeah. So in general, you can combine these two. Yeah. You only need to consider a repeated squaring and a cubing. Yeah. No other, possibilities to be considered. Yeah. Yeah. So with these two possible ways, then you try your best to use the minimum number of multiplications. Yeah. So that's for question number 18. Okay? All right. Yeah. Number 19, yeah. So then, because you have two terms, yeah, different from number 18. Yeah. Two terms, then there is a, special technique we may need to use, factorization. Yeah, because these two terms, they have common factor, right? Yeah, it's very easy to see. They have common factor, so you can factor that common factor out and try to use the factorization to change the structure of the operations and try to reduce. So after factorization, then repeated squaring and plus cubing, okay? If necessary, right? Squaring or cubing, yeah, because here you have two tools. Yeah. You have two tools to use. Yeah. Two tools is better than one tool, right? Yeah. Using two tools is better than using one tool. Yeah. All right, so that's these two questions. The next two questions, yeah, are similar, right? Yeah, these two questions similar. Yeah. Let me do the number 20 first. Number 20, yeah. Look at the condition. This is the given condition. All right. First, without the given condition, you know how to solve it, right? Yeah, we did it in class, remember? Yeah, 19, it's an odd number, yeah. Yeah. Finding both maximum, minimum. We did it at the end of Module 1, Module 1, Part D. At the end, we solved the odd case. Remember? Yeah. So you just use that same method. Yeah. But now we need to add an extra condition. Yeah. But if you look at the solution, in that solution, in that old solution, we need to do some comparisons to get information of the given condition, right? Yeah. But here, the condition is given. That means you can save this many, yeah, because you need to do the several, yeah, this many comparisons.
using the given condition, you can save several comparisons. Yeah. So you need to, minus that many comparisons from the answer you get without using the given condition, right? So that logic. Yeah. All right. So question number 21, similar idea. Yeah. But here, the given condition is slightly different. Yeah. So here we need to, try to use the given condition wisely. Yeah. Okay. Yeah. All right. Now you have the experience solving question number 20. Yeah. So you only need to modify slightly on your solution from question number 20. Yeah. So here, in this condition, if you compare it with the question number 20, so this one, you need the elimination method to remove certain number of elements from the consideration. Okay? Consideration. Okay? Yeah? Because you look at the given inequalities, some of the elements cannot be the maximum and cannot be the minimum. So those elements can be eliminated immediately. Then after that, after you eliminate those elements, then you go back to the situation of question number 20, right? Yeah? So after the elimination, just use the same way to find a solution. Okay? Yeah. All right? Yeah. So, but both of these questions, you need to fully understand our previous, the one I mentioned, our notes, module 1, part D, at the end part, okay? The last topic, near the end. So that's the, the detailed solution there. All right. This one in class I mentioned. The first thing you should be very careful. Do not do expansion do not do expansion. Okay? Yeah, because if you do the expansion, you will have too many terms. You will work on too many terms. Yeah. So you will break the nice structure. Yeah. Because this structure, you need to keep the structure. Keep the structure. Okay? Yeah. All right. Then, when you work on this structure, yeah, first thing you need to use Horner's rule. Horner's rule. Don't forget Horner's rule. Okay? Yeah. So using Horner's rule, you can find the number of multiplications in the first pair of parentheses. Yeah. Let's say u. Okay? Yeah. So you could use a temporary variable u represent the number in the first pair of parentheses. Yeah. Also, v, also Horner's rule, v, second pair of parentheses. Then w, third pair of parentheses. Yeah. After that, p of x equals u to the fourth times v squared times w to the eighth. Okay? All right. To calculate that, another important technique you need to do. Okay? Now, try to share squares. Share squares as much as you can. Share the squares. Can you share the squares? Okay? Yeah. For example, I show you one step sharing squares. Yeah, because all the exponents are even numbers, right? So the first round we share squares. Can we write this p of x equals u squared times v times w to the fourth? Then they have a common square, because these three variable terms, u part, v part, w part, after we put it in a big pair of parentheses, all these three parts, they share the same squares, right? Yeah. So that's what I mean. Square sharing. Yeah. After that, can you do another round sharing, square sharing? Further, more square sharing, right? Inside the parentheses. Yeah. Yeah. Try your best to share the squares as much as you can to reduce the number of multiplications. The more you share the squares, the more multiplications you can reduce. That's the idea. Okay? Yeah. All right. Next question. This question. Then another special structure. Excuse me. You need to use Pascal's triangle. Can you recognize the given structure matches the one with, of the Pascal's triangle, right? Yeah. Yeah. So if you can connect to Pascal's triangle, yeah, so then you can represent it in more friendly way. More friendly way. All right? So that's one step. Another step, then you may need to calculate, okay, A of x plus B of x. Yeah. The next step, you may need to calculate A of x plus B of x. But when you calculate that, okay, do not calculate the terms separately. Okay. Yeah. When you do the calculation of A of x plus B of x, combine the terms. Combine the terms. First. Combine the terms first before you apply Horner's rule. Yeah, because after you combine terms, then you apply Horner's rule. Okay? Yeah. So you need to use all these techniques we have learned so far, yeah, to solve these problems. Okay? Yeah. Yeah. Otherwise, if you do not use these techniques, yeah, you will use many more multiplications, more than necessary. Okay? All right. Last two questions. Number 24. Number 24, similar, close to, excuse me, C, question number 16. Yeah. If you compare this question, you have extra condition. This condition is the extra condition, 5. That one is 7. We know 7 and 5, not too much difference. Not too much difference. Okay? Yeah. Yeah. The basic idea is the same. But here, this is the added condition. Okay? Added condition. Yeah. With an added condition, so you want to take advantage of this extra condition, right? Yeah. So you need to take advantage of this extra condition. Okay? All right. So here I tell you the goal. Yeah. Because in questions you have an answer, right? Yeah. You have an answer. So here, the worst you can do is this answer. Okay? Yeah. Yeah. The worst answer for this question is this one. Okay? Yeah. Yeah. Okay? Yeah? Because that answer you didn't use the given condition. All right, so now your goal, you try to do better. You want to do better than question number 16, right? Because you have extra condition, better than question number 16. Okay? So the goal, yeah. With, yeah, so with the given condition, try to reduce just one multiplication, okay? If that is possible, one multiplication. Oh, sorry. Multiplication. Okay, yeah? That's your goal. Okay? That is your goal. Okay. Because you want to use the given condition. You hope the given condition can help a little bit, can help you to do one multiplication reduction. That's good enough. That's pretty good. Okay? Yeah. That's pretty good. That's your target. Okay? All right. Then, the last question. Yeah. The last question, this one is the most challenging question of this assignment. So I put it at the end of the whole assignment. Yeah. All right. But largest, smallest, second largest, smallest. Yeah. Look at the case. So here, if we only look at largest and smallest, then we have the solution, right? Yeah, yeah. Even with a given condition, given condition, we did a similar question in some previous questions, right? Yeah. Previous, yeah. Look at the question 20 of this assignment, right? Yeah. So you have some experience already, okay? Yeah. But the new added part is this time you need to do second largest and the second smallest. Second largest and the second smallest. Yeah. All right? Yeah. But the basic setting, yeah, the basic setting. The basic setting, you can use that of question number 20. Yeah. But you need to do extra work, yeah, because second largest, second smallest, yeah. After you get the largest, smallest, yeah, you need to do extra work. Right? Yeah. And this part a little hard. A little hard. Okay? Yeah. Last one. Yeah. You need to do some smart work. Yeah. Smart work. Yeah. The good thing is you do not have too many elements, right? Only 8 elements. 8 elements in 4 pairs. 4 pairs, 4 ordered pairs, right? Yeah, because the order are given, okay? Ordered pairs. Okay? All right. Then you need to work on these 4 ordered pairs. Okay? Winners group, losers group. Remember, we use, that kind of special treatment. Winners group, losers group. Okay? Yeah. Do discussion. Okay? So then, second largest, second smallest. Yeah. All right? Yeah. All right, so let me stop right here. Yeah. Try your best. Yeah. Work as much as you can in this weekend. Yeah, but after the weekend, you still have a few more days, right? Yeah. So you have some breathing room after the weekend. Yeah. The deadline Wednesday. Yeah. October the 8th, Wednesday. Yeah. All right. Yeah. So let me stop right